Okay, this is Game Theory Lecture Part 2, Prisoner's Dilemma and Dominant Strategies. So, let's do that. So, our example, we're going to have 2 cons and 1 cop, right? And so we have 2 suspects being interrogated separately. Now, we treat this as a simultaneous game, even though you could think about the real-life setting as happening at slightly different times, as long as the 2 suspects aren't aware with any level of certainty of any of the choice that is made by the other suspect, then it is effectively the same as these things happening at the same time. So we can think of it as a simultaneous game. Same thing with, say, firms' production decisions, right? They could the actual decisions could happen at slightly different times, but if either firm is not able to confirm what exactly that decision was by their opponent, then it's the same as then we can think of it as being the same as simultaneous choices being made. All right, so we have 2 suspects being interrogated separately, and we'll say that the evidence is weak. So maybe the prosecution can get either of them for fraud regardless, but they can't nail them for the armed robbery of sticking up a 7-Eleven, right? And so they need a confession, right? In order to get the conviction that the prosecution wants, they need a confession. Now, the cops or the prosecutor are not a player in this strategic setting, right? The thing is that there are 2 different suspects in 2 different rooms, and they have both been offered these choices, right? They can confess or not confess. And what the prosecution has done is set up the terms of the game that is now going on between the 2 suspects, right? Because by defining their prosecution strategy for the suspects, right? Now the suspects know what their own payoffs are and what the payoffs of their opponent, who is actually their partner in crime, might be. So if neither suspect confesses, then they both end up serving 2 years for fraud. If both confess, then the prosecutor is able to charge both of them, and neither one really gets the deal and a reduced sentence. But if one confesses and the other does not confess, then the one who confesses only serves 1 year because they get a deal from prosecution, and their opponent or partner in crime ends up serving 10 years. So this setup is going to create what is commonly known as the prisoner's dilemma, right? And I should point out, right, that in this example, what we are looking at are negative payoffs, right? That neither suspect wants to serve any time in prison, right? So more years in prison means less utility. And often, particularly when we think about firms in strategic interactions, we're going to be flipping that around and thinking about positive payoffs, such as profits, right? So just make sure you're ready to tweak your mind around that switch in perspectives. Okay, let's turn off the screen share. So what does this actually mean, right? We have our 2 suspects, right? We're going to now fit this into our game theory framework, where we have our 2 suspects, who I have named Bonnie and Clyde. And so those are our 2 players in the game, right? And each of them has a set of strategies available to them. One last time, I'll emphasize that strategies and actions are the same thing at this point because there is only one set of actions available to the players. But when we think of multiple stage games and stuff, then a strategy will be distinct from an action. So Bonnie could choose to confess, or she could choose to stay quiet, right? And so those are the strategies available to Bonnie in this game, and Clyde has the exact same set of strategies available. Note that we can have a very similar 2x2 game setting where the choices that the two players make are not the same choices, right? Here, this is going to be a symmetric game where everything about it has symmetry, essentially. But we could introduce any measure of asymmetry we want, even to these exact payoffs, and it would still be a strategic game. All right, so what were the terms that we set here? It was that if both players choose to confess, right, then they will both serve 6 years in prison. So we're going to denote like this, where the first value in these payoff matrices is going to be the row player's payoff. The row player is Bonnie, right? And the second value is going to be the column player's payoff. Column player here is Clyde. Comment that in your textbook, they're going to break up these individual cells in the matrix and along the diagonal and split the payoffs like that. But that in writing out your own matrices, that can get confusing and make it harder to look at. It works in the textbook because of the color shading that they're able to use easily. So we'll stick with this format of first payoff is for the row player, second payoff is for the column player. All right, now if both Bonnie and Clyde stay quiet, then the deal was that they each end up serving 2 years in prison, right? Because they can't get out of being charged for fraud, but they don't end up serving time for the armed robbery. And the slightly harder question is how, if you're trying to set up this matrix for yourself, is how to do the payoffs for the other two cells, right? Where Bonnie has stayed quiet and Clyde has confessed. The deal was if only one person is confessing, they get a reduced sentence of just 1 year, and the other player or the other suspect, right, gets 10 years. So Bonnie is staying quiet, Clyde is confessing, he gets the deal, his payoff comes second. So Bonnie ends up serving 10 years in this case, and Clyde just serves 1, right? Similarly, if Bonnie is the one that confesses, she only serves 1 year, and Clyde, for staying quiet, ends up getting the 10 years in that outcome up there. Note, we have sets of strategies for each player. Each individual cell in this payoff matrix, right, is a particular outcome, and these are the payoffs to the players in each of those outcomes, right? So if I wanted to refer to this outcome is Bonnie has confessed, or sorry, Clyde has confessed and Bonnie has stayed quiet, so Bonnie ends up serving 10 years and Clyde only serves 1 year. All right. Now, the objective of all of this, right, is to be able to identify the likely outcomes here. And the contribution that we're able to easily make, right, in this setting, because it's one of the most straightforward games we could think of, is that this outcome that obviously is the one that that seems preferable for the pair, Bonnie and Clyde, is never going to happen. If this game captures the real payoffs and options available to the players, this literally should never happen, right? Because both players want fewer years in prison, right? And given Clyde's options available, right, Bonnie therefore always wants to confess, right? Because just look at the options available to Bonnie. If Clyde is confessing, then Bonnie's better off if she confesses. If Clyde is staying quiet, Bonnie is still better off by confessing. She only gets 1 year instead of 2 years if she confesses, right? So in either case, the best thing for Bonnie individually is to confess. Reverse the order of thinking about those things, right? And Clyde has the same trade-off to be made, right? If Bonnie is confessing, Clyde wants to confess. If Bonnie is staying quiet, Clyde still wants to confess because 1 year in prison is better than 2 years in prison. Think back to the definitions we did in part 1, right? That is a dominant strategy, right? If regardless of the possible choices that her opponent might choose, Bonnie always wants to choose confess, then I have a strictly dominant strategy for Bonnie. She's always going to choose confess. I look at the other way around and I say, okay, what about for Clyde? If Bonnie is choosing confess, then Clyde's options are 10 or 6. He wants the 6. And if Bonnie is choosing to stay quiet, which I actually already know she won't, but still, Clyde wants to choose to confess, then Clyde also has a dominant strategy that is confess. So because both players have strictly dominant strategies, right, we have a dominant strategy Nash equilibrium that is confess, confess. The caveat, right, to tag along with this is, or the criticism is, well, but wouldn't these players want to collude and get to just the what we might call the cooperative outcome, where they each only get 2 years in prison? Absolutely, they would want to, right? But if we have defined their payoffs properly, then that is not achievable because they don't have a way to enforce that the other player does as they agree, right? Even if we allow them to have a conversation before getting into the interrogation room, or if you suppose that when a pair gets together to commit crimes, they might have a tacit agreement about how to handle this, right? That, no, I'm never going to confess because we both know that we'll be better off if we don't confess. Once they're in the room, everything has, right, is when it comes down to the line, and this is the reality of the game, right? Or that's what we're imposing when we impose this structure on the game, right? So even with some sort of agreement ahead of time, we should still expect this outcome, right? Even if they tried to come to an agreement that would enforce that outcome, unless there is some enforcement mechanism, right? And so we could hypothesize, right, that the sort of honor among thieves and everybody hates a rat kind of criminal code of conduct, right, is an effort to undermine this prisoner's dilemma setup, right, where the prosecution is always trying to set the stage so that this is the game being played, and the practice within prisons of making life difficult for individuals who have ratted on their accomplices is an effort to break down this setting and essentially increase the costs associated with confessing for either player once they are in prison, right? And so what we would have to do to make this not a Nash equilibrium is for the cost of having confessed to increase this from 6 years to the equivalent of a 10-year prison sentence. 6 terrible years in prison rather than 10 years unmolested might might break down the expected outcome in this setting. However, right, if we accept that these are the actual payoffs associated with the game, this is the only outcome we should ever expect to occur, right? Because for both players, it just doesn't make sense to stay quiet. I can have 6 or 10 years if I'm Bonnie, or I can have 1 rather than 2 years if I'm Bonnie. I always want to choose to confess. And similarly for Clyde. That is prisoner's dilemma, and this is our concept of a Nash equilibrium, right? Where at this outcome, even though there's a preferable outcome over here, right? It's a Nash equilibrium because for either player, the only thing they can do is change from confess to stay quiet, and the only thing that will happen for either of them is they increase their own sentence from 6 years to 10 years, right? Which is a strictly negative thing for them. Right, that is it for our first example of Nash equilibrium and this prisoner's dilemma example. We'll be back with part 3, where I will cover several other examples that do not have these strictly dominant strategies.